Okay, we're at Roman numeral 2 on graphing exponential functions. Okay, this may be new. Up until this point in this class, we've always graphed functions that had x down in the base, like y equals 3x, or y equals x squared plus 1. The x was down in the base. Now we're going to look at graphing things where x is in the exponent position. Those are called exponential functions. We have two types of exponential functions. We have exponential growth and we have exponential decay. The only difference is when you're looking at the function y equals a to the x. If your base, a, is bigger than 1, you have what's called exponential growth. So we're going to look at the example y equals 2 to the x. The base is 2, the x is in the exponent position. Anytime you have an exponential function, your three favorite x values are going to be -1, 0, and 1. Why? Well, because they produce nice points. If x is equal to -1, and you plug that into your function, what y value are you going to get? Y equals 2 to the -1, which is the same as 1 over 2, so 1/2. If you plug in 0 for x, what is y equal 2 to the 0? Anything to the 0 power is 1, except 0, and 0 to the 0 is undefined. Okay, for the third point, y equals 2 to the 1. The y value is 2. So go plot those 3 points. You have -1, 1/2, 0, 1, and 1, 2. So your function looks like that. Questions? If you were to graph it on your calculator, go to your y equals button, and you would type in 2 raised to the power of x. On my window, I'm going to change it to -4 to 4 on my x's, and maybe -2 to 6 on my y's. Does that look like the function you graphed? Beautiful. Questions on exponential growth? Yes?
Can you show me how you do that again?
On the calculator, go to your y equals, you type in 2 to the x, and then just hit graph. You can also look for your points. How? Hit second table, and those will give you the points. -1, 1/2, 0, 1, and 1, 2. If the base is bigger than 1, you have exponential growth. If the base is between 0 and 1, you have what's called exponential decay. Go find your 3 points that you're going to graph. Your 3 favorite x's are -1, 0, and 1. Okay, if you plug in -1 for x, what is 1/3 to the -1 power? What does the -1 do? It reciprocates it, so that becomes 3 over 1 to the +1, right? And what is 3 over 1? 3. 3 to the first power is just 3. If you plug in 0 for x, what is 1/3 to the 0 power? It's 1. If you plug in 1 for x, 1/3 to the first power is 1/3. Something to look at. You had 1, when x was -1, it was just 1 over the base, right? When x was 0, it was 1, and when x is 1, it is whatever the base is. And that was true on exponential growth and decay. Okay, go plot those 3 points. -1, 3, 0, 1, and 1, 1/3. On your calculator, if you were to go to y equals and type in 1/3 as a fraction and raise that to the power of x, and you hit graph. Now, I don't like that window. That's why last time I played with it a little bit and just did maybe -4 to 4 on my x values, and then -1 to maybe 5 on my y's. And it stretched it out a little bit more. You could see it. You got the point 1, 1/3, 0, 1, and 1, 3. Okay, some characteristics of exponential functions, both growth and decay. What's the domain here? What x's can you plug in? Anything, right?
Yeah.
So all reals. So some characteristics. The domain is going to be all real numbers. The range, what y values do you have up here on the exponential decay? Do you have any of these y's? No. Do you have y equals 0 ever? No, because it goes down to 0, never gets there, right? So anything that is bigger than 0, how do we say that for the range? Open parenthesis to 0 to infinity. On the graph right up here on the exponential decay, do you see that there's a horizontal asymptote here at y equals 0? Now, those 3 things are still true of the exponential growth up here. The domain is all reals. The range is only from open 0 to infinity. And there's a horizontal asymptote here at y equals 0. For the points, you're always going to have -1, 1 over a, 0, 1, and 1a.